All right, so finally, linear regression. Now, it's linear. You're going to learn about linear regression. You learned about linear correlation, Pearson. Remember, Pearson product moment correlation. That's the full name of the test. And it assumes that the data follow more or less a linear pattern. So those XY points on the scatter plot, if you were to look at them, you would see that they more or less follow a straight line. Now, if we see that there is a relationship between X and Y and that the relationship is linear, we can then use a technique called linear regression to predict, let's say, what will Y be for a given X? Or what will X be for a given Y? So we can use one variable to make predictions about another variable, all right? But we actually get far more out of regression than just can we use one variable to predict another variable. When we run a regression analysis, we get the following information. So, number one, as I've just reviewed, you're going to get the information that you need to predict Y for a certain or a given value of X. So in other words, if I tell you X equals 5, you're going to be able to predict what Y will be. All right. Now, that's only if there is a relationship between X and Y. If there's no relationship between X and Y, then you can still make a prediction, but you would be guessing, right? Because there's no mathematical relationship between them. So knowing one tells you nothing about the other. So you may as well be guessing, right? Don't bother using a formula. You can just guess and you'll be just as accurate as you would be with a formula, okay? Now, just a FYI, there is a formula for predicting Y. The formula changes a little bit for predicting X, all right? When we run a correlation, it doesn't matter which variable you want to call X and which variable you want to call Y. It really makes no difference. The R value is not going to change. But with regression analysis, it does matter. You have to know which variable is going to be X and which is Y. X is the variable we call the predictor. All right, it's the variable that we're going to use to make our prediction. Y is the predicted variable. All right, so it's the one we're trying to predict. So X is the predictor, all right, predictor, OR, and Y is the predicted. Now, in this class, we're only going to stick to one equation, and we're just going to learn how to predict Y. We're not going to cover the other way. Right. Number two, from the regression analysis, we're also going to be able to see how much of the variability in the Y scores is explained by the variable X, or if that's in simple regression, we're going to use X to predict Y, and so we can look at the variability of the Y scores and determine how much of that variability is explained by X. But in multiple regression, which you're going to learn about, in multiple regression, we're using more than just X to predict Y. So let's say we're using A, B, and C. All right. We can then calculate the amount of the variability, the percent of the variability in the Y scores that is explained by the combination of A, B, C. All right. So you can use multiple variables to predict Y. So this is R squared, right? We just learned about that. As soon as you realize that you're trying to explain the variability in the Y scores, your mind should automatically shift to R squared. That's R squared, right? Trying to understand why the scores for variable Y are all over the place, if they are all over the place. Okay, third use. If you're using two or more predictor variables, so in other words, if you're using two or more, it's like saying X's, right? But we can't call two variables X. right? We have to give them different names. So let's say we're using the predictor variables A, B, and C. Variable A, variable B, variable C. Those are our predictors, okay? What we're using to make the prediction. Then we can actually figure out the relative contributions that each is making. In other words, what we're going to be able to do is we're going to be able to determine whether all three are making significant contributions to the prediction, or maybe only one of them is actually contributing to the prediction significantly, or maybe there's two, all right, or maybe none. So we're going to be able to determine that with if we're doing multiple regression. Okay, now remember this, keep this in mind. We said that if there's no correlation between X and Y, if you did regression, you would just be guessing, right? There's no relationship there. Why do you think that you're going to be able to use X to predict Y? The other thing that you should remember is that when R increases, either in the negative direction or the positive direction, when we see an increase in R, it means the relationship is getting stronger. So stronger relationships are certainly going to give us better predictions, right? On average. Doesn't mean that we're always going to be predicting and every single prediction is going to be great. But on average, our predictions are going to get better and better as R increases.